Good afternoon. Welcome to the second live session interaction class for programming in C++. So, we have received a couple of questions. So, we will start with those and then whatever questions come up during the session we will try to address them. So, I am here and I am assisted by your well known TA Mr. Himadri Bhuiya. Okay. So, let me go to the first question. This is on operator overloading. It says if let if a iStream operator is overloaded in a class and let class A is inherited, class B is inheriting class A, okay, and iStream operator is overloaded in it too, how to call A : operator in B to input data members of A from class B by just doing C in B, where B is an object, etc. Sehaj Anand. Now, I think you are kind of little bit getting the context wrong, because we will have to look at how actually the IO streaming operators are realized overloaded for classes. They actually cannot be overloaded as member function. So, what I will do, I will just take you to let me just go out of this and take you to the this is the presentation from module 19, which discussed this whole issue of overloading IO operators. So, I can start from here. So, basically the idea is if I have a class, for example, this is already there in the video and you have the slides as well. So, if you read it carefully again, you should get the point, but I will still quickly go over that. So, what we are trying to do is we are trying to check if operator output stream for class, I mean input stream and output stream have very similar, I mean exactly similar style. So, there is a complex class for which this operator is required. So, that I can I mean if I have objects like D1, D2 for the complex class, I should be able to directly write this, which is I can directly output this, and for that I want to overload the operator output streaming. So, the first question that you have to understand is what should be the signature of that operator. Very clearly, the operator has to deal with two different inputs. One is the output stream and two is the object that you want to output to that output stream, right. So, if we look at this operator, this is the name of the operator function. So, the possibilities are it could be a global function, it could be done as a global function. So, I have a first parameter which is the output stream, the second one which is the value of the user defined type, in this case complex. Since we are outputting, we do not expect naturally we do not expect to change the object while we output. So, we pass it as a constant reference. If you are doing an input stream operator, naturally this const will not be there, because you will expect to read from the input and change the object into which you are reading. And the return value of this operator function has to be also the output stream by reference. This is required because if you look into this kind of a chaining operation that you would like to do, which actually means this. So, you can see that for the first instance of this operator, this parameter or the first parameter is actually an O stream object. For the second one, naturally this whole thing should also be an O stream object. So, that you can do this kind of chaining in the in doing the output. So, which means that the operator function has to take a O stream and has to actually also return that O stream after the outputting has been done on that. So, that tells us what could be the basic structure of the operator function if it is global. Now, the other option is it could be member function, and since two classes are involved, the O stream class and the complex class, the user defined class, there are two options again. It could be a member function in the O stream class. So, if it is a member function in the O stream class, naturally this its name will be O stream : operator output, and it will take only one parameter now, because the other parameter, which is the O stream object on which you have this member function, will be implicitly available. And for this operator, for this parameter, user defined parameter, it will do the output operation, and naturally by the same logic as given earlier, the output will have to be by reference the O stream that you have, the current O stream object for this O stream member function will have to be output. The third option is naturally that the user defined class is involved. So, I could try to overload this in the user defined class. So, in that case I will write it as complex : operator output, and naturally now I will have to take the O stream as a parameter, and you can see that the O stream in every case as a parameter will have to be a non-constant reference, because you are making changes to O stream, because you are writing to it, and you will have to return that. So, these are the three possibilities that exist if we just analyze the call, right, how this will have to be called. So, next let us try to see, given this, what are the possibilities. So, if we have this, okay. So, now I have this. So, this is if you have to do, if you do it as a global function. So, which is very straightforward, you are overloading the global function itself. So, you are taking this, you are taking two parameters, and you are writing the complex object to the output stream, or you are reading and filling up the complex object from the input stream. But since these are global functions, necessarily what will mean that your data members of the complex class, which these output streaming or input streaming functions have to access as global function, these data members will now have to have a access specifier which is public. So, but that, as we know, goes against the basic encapsulation principle of object design. We want the data members to be private and encapsulated. So, global functions can work, but they break the encapsulation. So, that is a basic problem of having them as global functions. Okay. So, then let us look at the other options. So, the other option is you make it a member function. So, say if we make it a member function in the O stream class or I stream class for the other operator, then the problem will be solved, but the problem here is that O stream is a library provided class. It is in the C++ standard library. So, we are not allowed to make any changes into that. So, we will not be able to write this as a member function in the part of the O stream class. So, this possibility is also ruled out. So, the third possibility remaining is you can define that as a member in the complex class, the user defined class. So, it will looks like this, which takes O stream as parameter. But if you do that, then this, if you have an operator like this, then what is the first operand? You have written it for the complex class. So, the first operand for this operator would be the complex class object D on which you are invoking this, and the second operator is whatever is the parameter of this function, which is some O stream object, which is a C out. So, it will, if I make this function as a member function in the user defined class complex, then it will have to be invoked as this, whereas the natural notation for doing this is in this order. So, I can do this, but then the natural infix notation of the operator will get changed, which spoils the whole natural syntax. So, by looking at these, we find that all the three options, I make it a global function, then the encapsulation gets broken. If I want to make it a member function in the O stream class, then I am not allowed to do that because it is a library, and I cannot do it as a member function of the user defined class complex, because that spoils the natural syntax. So, given that there is only one option that remains is I make it into a global function, I make it into a global function which I make as a friend function. I can make it as a friend function. There are some options given here, but what is a simple option is you make it a global function, but you do not break the encapsulation of your user defined class. The data members, keep them still as private, but make this as a friend function in your class. So, that being a friend function, it will be able to access your private data members, and we have already seen as a global function how it can work for your output, or if we talk about I stream, then the input purposes. Okay. So, this is the basic mechanism. So, I just wanted you to recap you on that. You can again go over to the videos also to check. So, let me now go back to the original question. So, here is the original question from Sehaj. So, okay. So, you are saying that I stream operator is overloaded in class A. So, class A has some operator to be able to read from the I stream, that means to be able to read from C in, and then class B inherits from that. So, class B has this is this. So, it should also be able to do it from C in. So, if this is the mechanism, then just understand that what did we say, that for class A, I actually have this as a friend function. So, whatever it may have. So, I actually have a friend function. So, I have friend I stream, the return type, operator input, and then I have I just erase that. Then I will have I stream, say I s, and I have, say, since this is A. So, I will have A ampersand A, right. And then I write the code to do that. I finally return I s. So, this is what I will have in class A. And what I will have in class B? Class B is inherited. So, I will have class B public colon A, and now as you know, this I stream operator that I have created here, written here in class A, is a friend function of A, and you know that the friendship does not get inherited. So, if I come to class B, I will not have a input streaming operator. I will have to separately specifically do one for class B. I cannot inherit the operator as you wrote. There is no A colon colon operator I stream, that is, there is no A colon colon operator this, because it is not a member function, it is just a friend function. So, it is actually a global function. which only is taking an appropriate input of type A reference. So, for B also I have to write the same thing. I have I stream ampersand operator redirection I stream ampersand is, and this time I am writing it for the class B, the objects of type B. So, I will have a B reference B, and then I do this, I will return is. Now, if I actually if I do C in of B, then this particular operator will get invoked. Now, if we want specifically within that while I process this, I want the base part of this object to be filled in by reading using the operator input stream as befriended by class A, then what we will have to do? There could be different mechanism, but one mechanism could be that I could take a reference to class A, which is of type class B, I mean the B object, which is of type class A. So, I do something like A ampersand, I am sorry, B, and then I do C in A. Now, what will this C in A? A is a reference to the A class of object. So, this C in A will invoke this operator. So, but this kind of a explicit handling of the type will have to be done, because the inheritance will not take care of this case, as here the operator functions are friend functions. So, it is a little long answer to your whole question. Of course, if you send me any specific code that you are trying to write in this context, because usually such kind of things may not be required, because usually what you do, when do you do the input streaming, when you typically when you are constructing the object. So, these two will have two different constructors, and the constructors themselves, once you are in the constructor, you know as to which object you are, which type you are dealing with, and the corresponding I stream can very easily be invoked. But if you have a real situation that you are trying to address, trying to take care of, please send us the code, and we will go through and try to advise that and put up in the forum. Okay. So, let me go over again, it does not change in the slide mode. Okay. So, the next question, what if we call the base class function with a base class, what if we call the base class function with the base class function definition, that is parameter type defined in the base class, that is overloaded in derived class with different parameter. I am confused about what you are asking, but possibly if you are asking this, say I have A and I have B, and in A I have something like void f int, and in B I have say void f let's say it's a what, let's say cat star. Right. Now, if you are asking what will happen in this situation, you will have to understand that if there is a public inheritance of B from A, then in B actually you also have a void f int. So, is overloaded in the derived class with a different parameter. So, it is overloaded in the derived class with a different parameter. So, in class B actually you have two versions of f, they are overloaded, one which is inherited from this. So, your B colon colon f, which can take int, is actually same as A colon colon f, which takes int, and then you have a separate B colon colon f, which takes cat star. So, on a B object, if you on a B object, if you called b dot f with say 10, then it will call this function, which actually has not been overloaded, it has not been written. So, this will actually call the function in A, whereas if you call this say I have cat star p c. So, if I call f dot p c, then it will call the function that you have overloaded in the class B, right. So, this is probably this is what you meant. If you meant something different, please do write to us explicitly giving your code and the problem that you are facing. We will try to give you the solution. We will publish it in the forum. Okay. Sir, can you describe static and dynamic binding with concept and simple example? Naveen, this has been discussed at length in the videos. So, you can't expect me to do that same thing here. Please try to understand, please go over and read those. Himadri has very painstakingly pointed out the modules where you will get this information. As you can see, the static binding or early binding or compile time binding has been discussed in several modules, referred in several modules 8, 9, 18, 19, and dynamic binding is what we have. So, the basic point is if I can just quickly tell you about the required issues, we will find that let us say suppose I have a class what went to this, I have a class A, let us say, and I have a class B which is inherited from A, then I have their details whatever. So, now the question is suppose I have created a B object and suppose I have a pointer to of type A which points to the B object, right. It is always possible because a base type pointer can always point there. Now, the question is what is the meaning of say a function B pointer f. Let us say this has a function f and class B also has a function f. That is the basic question. What is the meaning of this, or what is the meaning of B dot f like this. Now, if we say if we are going by I am sorry, this has to be, this is not B, this is P, this is P, the pointer that I have. So, it is a P pointer f, or what will happen if I do P dot f. Now, the question is if I do P pointer f, then what do I have? I have a pointer whose type is of class A. So, it expects a class A object. So, by that logic, this should call A colon colon f, but the reality is that it actually points to a class B object. So, if it has to go by what object it points to, then it should call B colon colon f. Which one should happen? Now, the question is if you just look into P pointer f and you are compiling, let us first take the situation when you are just compiling. So, when you are compiling, you just know that this is of type A, pointer of type A. You do not know, it could have been that instead of pointing to ampersand A, it is also possible that P points to instead of pointing to a B class object, it could point to a class object also. So, while you are compiling, just looking at this code, you will not be able to figure out whether it is actually pointing to a class object or pointing to a B class object, right. So, two mechanisms have been given. The first mechanism is that you decide which function will be called solely based on the type of this pointer. irrespective of whether it points to a class object or a B class object. You just know that P is a pointer of type A, it points to a type it points to a object, it is of type A pointer, class A pointer. So, if I invoke it, it will always invoke the function of class A, member function of class A, irrespective of whether it is actually pointing to a class B object or it is pointing to a class A object. Because at compile time I only know that P is of type pointed to A. If we follow that strategy, then that is what is called static binding. In contrast, if I want to say that no, I would like to, if P, this pointer P points to an object of class A, then I would like to, that is if the situation is like this, then P pointer F should actually call the function of class A, which we were doing earlier also. But in this case, when P is actually pointing to an object of class B, I want it to call the function of class B. So, depending on the actual object it is pointing to at the runtime, I want P pointer F to be either bind with A colon colon F or bind with B colon colon F, depending on the type of the object it is pointing to. So, this is a decision which cannot be taken at the compile time, this has to happen at the runtime. So, this situation is known as dynamic binding. By default, all member functions are statically bound. So, in class A, I think this has got pretty cluttered, let me just clear out and write once more. So, in class A, if I have a function void f like this, and then I have class B which is inherited from class A, and I have void f again, but certainly the implementation possibly would be different. If I do this, then it is static binding. That is, P pointer F will always, no matter which object P is actually pointing to, P pointer F will always bind with A colon colon F, because P is a pointer of type A. To make it dynamic, we write a specific keyword virtual before the return type of the function header. If I write virtual, then this becomes a dynamic binding. So, now P pointer F will point here if it means A object, but it will point to B colon colon F, that is this function, if it points to B object. So, at the runtime this will get decided, and for that we have discussed the mechanism at length. You will please go through the videos and the slides again. The whole mechanism of virtual function table or similar things are used. I hope this answers your question. If you have any specific codes or issues to point out, just let us know, we will answer them again. Oh, this is a, a non-technical question that probably many on the forum was asking how the final score will be calculated for this examination. So, Himadri has put in record that there are 3 components. One is the assignments that you have done, total of 6 assignments were given, that 8 assignments were given. So, out of those 8 assignments, the best 6 that you perform will be taken, and that your performance in those best 6 will comprise the 25% marks in the final score. Then you are having a non-proctored programming test for 20 marks. So, your performance in that will contribute another 25% of the final score. And finally, the proctored examination that you will have, you will contribute, which is be for 80 marks, will contribute the remaining 50% of the final score. So, 25 from best 6 out of 8 assignments, 25% from non-proctored test for 20 marks and 50% from the proctored examination of 80 marks is what will be your final score, and that is what will be used for the purpose of your grading. Right. I hope this is this answers your question on this. General philosophical question, Prashanthi, how to improve coding skills easily? There is no easy way to success. I mean, I do not know of achieving any success by doing things easily. So, there is no easy way to improve coding skills. You have to learn the programming language well, and these are some of the things that you can try. You learn better not by reading, but by doing, actually writing code, trying to compile, run them, try them out with different inputs and so on. Try to grasp the fundamentals of the language, the features as much as possible. That will keep you in good state in a long term basis. You practice with coding, there are a lot of free online training sites, you may use them. Seek for more online resources. There are several resources, I mean, people put up, and there are several good project sites. And it's just that, I mean, it's just reading the code or just reading the language does not help, right. Keep on writing and practicing the programming. Sir, please explain me how we merge two files together using appending. Abhishek Mishra. This is simple. So, if there are two files, the solution is given here. So, what you can do when you actually open a file. So, FP is a file object. So, when you open a file, you can specify the mode in which you are opening. So, if we assume that file1.txt and file2.txt are two files that you want to append one of the other, and if we assume that you want to append file2.txt in file1.txt, then open the first file in the append mode. We have shown how to do it, ios::app, that is the append mode, and open the file 2 in the ios::in, that is read only mode, and then you should be able to read from one file and read symbols from one file and append to the other, right. So, that is, but you can do it in several other ways also. Actually, in many cases, unless you want to do some transformations, because you have not mentioned what kind of files you want to merge. For example, if you want to, which is a common scenario, is if you want to merge two text files, then often you may not do it in the program itself. You could do it using the scripting of your system as well, that will help you do that. Otherwise, appending is a very simple thing, you just read from one file and write to the other, that is simply what will do. What kind of questions will come in the online programming test? The kind of programming assignments that you have been doing. If you have done the programming assignments well, then you should not have any difficulty in handling the programming test. They will be very similar to those. Okay, I think that was the previous set of questions. Is there anything from the live session today? Are there people actually in the live session?
Most of the questions I have answered.
You have answered.
That is related to
exams and all that. Okay. So, let us wait for 5 minutes still if there are some questions come, otherwise we will wind up. There was nothing I think here to talk about. So, our non-proctored test is tomorrow, 28.
Two sessions. Session 1 will be at 11 o'clock.
Session 1 will be 11 o'clock. This for 1 hour.
1 hour.
1 hour.
45 minutes.
45 minutes.
11 a.m. to 11:45.
11 a.m. to 11:45 is the first non-proctored test.
Then session 2 at 9 p.m. It will continue up to 9:45.
9 p.m. the 9 in the evening to quarter to 10. 45 minutes. Okay. And the proctored examination is on 31st, that is Sunday. So, that will also happen on two different sessions as it happens. Okay. Okay, good. Actually, before the examination, you should not only watch the videos carefully and follow the presentation, but you should carefully look revise through all of the 8 assignments. I mean, whether or not you have been able to solve all problems or not. So, you look, even if you have been able to solve, or if you have not done some problems right. So, please go through them, look at the solutions, look at the different options, look at the reasons of why the solution was correct or not correct. So, I would strongly advise that you revise the presentation as well as the assignment well. This is critical for doing well in the non-proctored programming test as well as the proctored examination. Okay, so that is all. I think there is nothing else, right? So, should we wait or
someone is asking about clarify virtual function table. Can you explain about deep copy and shallow copy?
did we talk about deep copy and shallow copy? Huh? We talked about that. Those are generic concepts. Let me just check. I think here if you see, so if you this is module 14 and I think slide 21 or something. So, if you look into this, we have this has been explained pretty well, that while you are doing this, while you are doing a copy, the question is if you have an object pointed to by a pointer, then so if you have a suppose I have an object and I have a pointer which points to this object. So, what if I copy this pointer? If I copy this pointer, then I get in another location I have the same address value, and since I am copying, what will happen? This will be something like this. So, there are two pointers now, P and Q, but there is necessarily only one object. So, this is what is called a shallow copy. Other I could have done, I can try to realize that I have a pointer P, and when I copy, say when I copy P to Q, I will have a new pointer Q, and q does not point to the same object. It does not point to the same object, but even the object that was pointed to by p, like the object that was pointed to by p here, the object that was pointed to by p here is also copied, and q points to that copied object. So, it is a case of a deep copy. Now, most often what happens by default is if you are using the default copy constructor or default copy assignment operator, then what will happen is you will have a shallow copy done. So, you have two objects, you apparently have two objects. So, this is a part of one object, this is a part of another object, and you are happy that you have made a copy of that, but one of the field p holds pointed to some other object, and while copying that p has got copied as a field q, which also points to the same object. So, now later on when you say destroy this object, then by that destructor possibly this object will also get destroyed, while the copied object still continue to remain in existence, and you have an inconsistency in that. So, the moment you have copied objects, you have to decide as to which kind of copy protocol you are trying to follow. So, here we talked about the deep copy, and we also showed what happens when you do the shallow copy. User has not provided a copy constructor and compiler has provided a free one. The free copy constructor just performs the bitwise copy. It just copied the pointer field, but not the did not create a copy of the pointed object. So, only the pointer is copied. So, as I have shown that while you execute, actually you will get a runtime error because your object has got lost. So, just try to run this code, the two codes compare, you will understand the difference between the two. Okay. Virtual function table. So, I just discussed about the virtual functions. Okay, so let me just. So, as I said, I responded in reference to someone's question in terms of static and dynamic binding. So, but if you are talking about virtual function, then you are in a situation of naturally you are in a situation of dynamic binding. So, I have a class A, let us say this class as void f int, it has a say another function void g say double, and you have say this one is virtual, and you have a class B which is derived from class A. So, you have this, and you have say void f int here, and you have a void g double. Right. Now, the question is that if in this case, if I have let us say a pointer p, I have a B class object B, and say the pointer points to the B class object, but it is a type pointer. And if I try to ask questions like what is B dot say f, what is B dot g, what is p pointer f, what is p pointer g. Suppose I want to find this out. Now, what will happen? So, what you know in this is, in case of say f, this one, it is a non-virtual function. So, there is a static binding. So, this will call the statically bound function. This is a B type object. So, it will call the f int of the B class, which is clear. Similarly, this case B dot G 2.1, G, what is G? G is a virtual function. So, it is a dynamic binding, but I am using the object directly to invoke it. So, in which case it is resolved directly from the object. So, it will invoke this. These two are easy. Now, what happens with p pointer f? P pointer f, what is the type of p? The type of p is A type, and what does it point to? Is B type. Now, comes the question of whether it will, this will call A colon colon f, or should it call B colon colon f. Similarly, here the question is, if I do p pointer G, whether should it call A colon colon G, or it should call B colon colon G. That is what the whole. And we said that if it is a non-virtual function, f is a non-virtual function, so it should call this. But if it is a virtual function, G is a virtual function, then it will call this, even though the pointer is. So, what can we have more? That suppose let us take another pointer q, which is also of A type, and let us take another object A and let q point to A. So, q points to an A type object, and p points to a B type object, but both of p and q are of type A. Now, here since q points to a type object, this will call A colon colon G, whereas this points to a B type object. So, this will call B colon colon G. The point is, you cannot make out by just looking at this code at the compiled time as to what object it will point to. So, for that purpose, the whole story of virtual function table is done. So, what is done is, moment a function is declared virtual in a class, you construct a table, say this will construct a table which has the pointer to the virtual function. Now, this particular virtual function table is for class A. Okay. So, I can think of that in the object, say in the A object or in the B object that I have one pointer at the top, which is the pointer VFT, which tells me whether I am accessing the virtual function table of class A or similarly the virtual function table of class B. Now, what you do is, if I have that, then I can say okay, p pointer G I have to compute. Now, what I have done is, in the virtual function table of A, I have inserted the virtual function that is defined in A. What happens in B? B is specialized from A. So, I inherit from and say at location 0 I have A colon colon G inherited from here. Now, if I do not provide a new signature of B of the function G in class B, I will have only this function. But the moment I provide this, I have overridden this virtual function. So, what will happen in the virtual function table? This entry will now be made as B colon colon G. The point to note is by making it through the virtual function, we make sure that the function g, which was first made virtual in class A, if that takes location 0, then in the subsequent classes, say here in class B, which is inherited, the function g will also happen at location 0. So, I can say that if I want to do p pointer g, I will not do p pointer g, I will do p pointer VFT, which is this field, which is pointing to either this, if it is a class object, or VFT is pointing to this, if it is a B class object. So, I will say a p pointer VFT 0. So, what will p pointer VFT 0 be? If I have a, if p points to class B object, then p pointer VFT 0 is this location. So, this is actually B colon colon G. But if you look at q pointer G, as in here, which will be q pointer VFT 0, why 0? Because it is the same function G. So, the position cannot change, that is the correlation. This is, since q points to an A object, this is the VFT of the class A, and we have this as A colon colon G. So, if this is the whole function, then we will simply call this as 2.1, or we have this function, we will call it with 3.2. Now, you can see that in this whole structure, your function g is not hard coded. So, you do not have to say whether it is a function of class A or a function of class B. All that you are saying that go to the VFT of the current object and pick up the 0th function, and that 0th function should have proper entry of which one is the 0th function. Now, this mechanism of virtual function table is of course not available for functions which are non-virtual. So, this does not have that. So, here whatever is the type of the pointer, you directly make use of that and use understand. Now, what happens further in the VFT is in this case class A has a VFT which has only one location, which is A colon colon G. Class B has overwritten that, I have G redefined. So, again the 0th location of B will be B colon colon G, which is a different function. Now, it is possible that V has the function f it has inherited, it has made that into virtual now. It was not virtual in A, but suppose here I make it virtual. Since this f was not virtual in A, there was no entry of that in the virtual function table of A, but when B makes it virtual, then the new entry is created. Now, the location 0 is already taken. So, you make a new location 1, because B class B now has 2 virtual functions. But what is important to see is the order of the virtual functions as you go in the virtual function table, as you go down the hierarchy cannot change, because they are referred to by their position. So, the first virtual function that comes in takes location 0, then in a later class or in the same class later function comes in that takes position 1 and so on. And then for the actual implementation of the dynamic binding, we do an indirected call through the virtual function table. So, the object has a pointer to the virtual function table and you go to that table, and in place of calling the function by binding the function by name, you bind it by its location on the virtual function table and do the invocation. So, at the runtime, whichever is the correct object, it the class of that object has already built the virtual function table, which is a part of that object. So, it will get redirected through that virtual function table instance and the corresponding function will be. So, this is a whole mechanism. I think we had discussed this at length in during our presentation, the video also you could look up, but since this was a specific question and this is an involved concept. So, I just explained it once more. Anything else?
Why global initialization of static member is needed?
Why global initialization of static member is needed? Whether are you meaning initialization or you are meaning definition? These are two different things. So, let us take an example, class A again, and suppose I have static int n. Right. So, your question is why it is not just enough to just write this, why do I need to write int outside this class somewhere, I need to write int a colon colon n is 0, right. So, you are asking that, I am sure. Now, the point is there are three things. One is called declaration, one is called definition, and one is called initialization. For every variable, whether it is a data member or it is a static or it is a global, it needs a declaration. A declaration is which says what is the name of the variable, what it is type, what kind of variable. So, this is a declaration. Similarly, if I have int say p, this is another declaration. Now, a declaration does not just tells you that what is the type of the variable, what is the name, what is its size and so on, but it does not bind a memory location for that variable. For a variable you need a memory location, otherwise you cannot keep the value. So, that process of associating a variable with a memory location or allocating a memory for that is called the definition part. So, variable is defined if it not only been declared, you cannot define a variable without declaring it, because you will not be able to bind a memory location unless you know the type of the variable which is provided as a part of the declaration. So, the definition in the second part which has to happen, so that you get a memory for that. And the third is initialization. In the memory location that you are bound, have you provided a starting value or does it contain a so called garbage unknown value? That is the initialization. So, these are the three steps. Right. So, let us look at what happens if I had this. Then suppose I have a data member, non-static data member p, and I have a static member in the class int a. So, now suppose I have int. Now, what is a? So, I am saying that this is a variable a which is declared as well as it is defined at this point. Now, if a is defined, which means a has a location. So, there is a location for a which is pointed to by at the location what I find out from ampersand a. So, which means as a part of that layout I have a place for int, place for p adequate to hold an integer which is actually a dot p. So, if I create the instance of a variable, I do a declaration, in the process I do a definition, and when that happens the constructor of that object gets invoked. Naturally, constructor cannot get invoked unless the object is defined, that is unless it has a bound memory, because it will not have a place to work. And then what does a constructor do? Constructor is what does the initialization. So, it will do the initialization. So, by writing this, the way we have created the whole class structure, by writing this we are providing a declaration for A, we are having a definition for that binds the memory, then the constructor comes and checks that memory, puts in the different initialization values for data member. So, every data member in that process has been declared, defined and initialized. Question is what happens with this? This is not a part of the object, this is a static one. So, in the object's layout there is no location for it, because for the whole class as many objects as it might have, whether it is 5 objects, 10 objects, 10,000 objects, or the class does not even have a single object, this is external to all that. So, no object declaration will provide a memory to it. So, we have to provide memory to that, we have to define that somewhere. That is the reason you need to provide this definition, because this merely is a declaration. When I write int a colon colon n, why do I need to write a colon colon? Because this name n is scoped in the class A, and it is quite possible that there is some other class B which also has a static which has a name n. So, that they do not clash, we are providing it is to be done in the global space, this is to be done with, as we say, fully qualified name. So, once we write this in the global, the definition is done, the program will compile. Now, more often what we will advise is, since the whole principle is everything you start with a proper initialization. So, we will advise that let us have an initialization also, which is good thing, because unless you have an initialization, it is already defined in the global, you just might accidentally use it with the garbage value. So, let us have that initialization. That is the basic. The initialization part is not mandatory for the static data member to work, but static data member must have a definition outside the class in the global, because there is no other way it can get defined, right. So, that is the basic reason. Anything else? Okay. Okay, good. I think we had a good session. So, some of the deep questions, I think unlike most other sessions where we have a large number of more trivial questions, this time I think we have had really a few really involved questions. So, it was a pleasure responding to that, answering to that. So, this brings us to the end of the whole presentation interaction session and the process of the programming in C++ course from NPTEL, NOC, SWAM this time. So, now it is the time for you to perform in the examinations and do well. So, I wish you all the very best and here we sign off, myself and Himadri and other TAs of the program. Really, I wish you all a very good luck with your examination. Bus.